Let's talk about number 2 on the worksheet for this week, 7172. So I'm going to start with number 2 on the worksheet, which is the integral of e to the x sine of 3x. So I see the combination of the exponential with sine or cosine. So I know that not only is this a by parts problem, but this is going to be the wraparound by parts. So I'm going to do by parts twice using the same u and dv choice both times, and then algebraically solve for my answer. Okay, so it doesn't matter which way I choose the u and dv to start, as long as I choose the same way both times. So typically I choose e to the x as my u, so that's what I'll do here, and then sine of 3x would go over here. So that means I need a derivative over here and an antiderivative over here. So in this step, when I do the antiderivative, I need to be extra careful. What I'm really doing here is a u substitution for the 3x. So I have cosine of 3x. I'll need a negative on it to accommodate for the negative sign in its derivative, and then also a 1/3 from the u substitution. If you have a tendency to miss that 1/3 in that process, it's worth actually writing out more steps of that u substitution. Okay, so I'll take these pieces now that I have them and do my by parts formula. I have uv minus the integral of v du. So I know I'm going to have to do by parts a second time. I'm actually going to take a step and just simplify what I have here so I don't get too lost in the minus signs. So this 1/3, you have options for how to deal with. What I'll do is pull it fully outside of the integral. The other option would be to keep it inside the integral so that in the second by parts, it becomes either part of the u or part of the dv. But it should kind of shake out the same either way, as long as you don't lose it in the process. Okay, so I'm going to take this right here and do my by parts again. Because over here I chose the EX as the U's, I'll do the same thing here. Now, I give that warning all the time, and I usually don't mention what the consequences are if you don't. So just FYI, if you choose it one way here and then switch it the other way here, at the very end, what tends to happen is you'll get original integral equals some stuff plus original integral, instead of like, so it's going to stop you from doing the algebraic steps at the end. It's not always the case, but choosing the by parts the same way both times prevents the issue. So I always do it for safety. Okay, so we have e to the x here. And again, I'm doing a u substitution in this integration step right here. So cosine integrates back to sine, and then I'll have a positive 1/3 on the outside from that u substitution. Section off that work, and I'll do by parts again. I'm carrying down the stuff from the previous step here. And then I'm also coming back for this 1/3, right? Because I have this on the outside of my integral, so it's on the outside of the by parts formula here. All right, so one more time, uv minus the integral of v du. Right, so what we're expecting and hoping for here is that after the second by parts, we come back to the original integral, e to the x sine of 3x, same thing here. So we know that we're in business. Again, for the sake of my algebra being as clean as possible, I'm going to take an extra step before I do the algebra and just distribute this 1/3 in. So I have original integral equals, I want to actually write that in. So I'm just going to transport this original left-hand side. So this term stays the same. This term, we just end up with a 1/9. And then we have minus this 1/3 and this 1/3 give me a 1/9. Just barely fits on the page. There we go. Okay, so I need to take this integral, this whole piece here, and add it to both sides so that it combines with this one over here. So I'm going to add 1/9 of this integral, add 1/9 of this integral. Okay, so on the right-hand side, it's gone. And I just have the two non-integral pieces. And on the left-hand side, I have one of these plus 1/9 of these would be 10/9 of that integral. Awkward number, but whatever. Right. And then the very last step now to solve for my desired integral is to divide by the number that's outside of it. So I'm going to divide by 10/9. So I have the original integral equals my whole right-hand side over 10/9, and then we throw on a plus c in the very last step. Now you have options here for simplifying for sure. Divided by 10/9 is the same as times 9/10 out front. And certainly that 9 could interact with the 1/3 and the 1/9. But anything from here, either simplified or not, is a perfectly good place to stop.